off to a great start with mass-to-mass conversions using stoichiometry. So I've got two mass-to-mass conversions, conversion problems that I'd like to go through as examples, and hopefully this will, be a good, good support to the worksheet problems that you're going to be doing the next few days. Okay, so here we have a balanced chemical reaction. This is calcium carbide. 1 mole of calcium carbide can react with 2 moles of water to produce 1 mole of acetylene. So this is the molecule acetylene. I'll just, for a little extra, the structural formula of acetylene is this. It's 2 carbon atoms with a triple bond joining them, and then a hydrogen on each carbon. It's a linear molecule. It's straight as a rod. So that's acetylene, and the other product that's formed is the ionic compound calcium hydroxide. Okay, so let's look at the question. It's wanting to know how many grams of calcium carbide would be required to make 23.6 grams of acetylene. Okay, so we've got 4 compounds here in the chemical reaction, but for this particular problem we're going to be focusing on just 2 compounds, and we're especially going to be looking at the mole ratio between them. And I think you can see that this is a pretty simple mole ratio, right? 1 to 1. Okay, so just like we've been doing in class, the way we start is we write down the thing that we're trying to find, the unknown. So we're trying to figure out how many grams of calcium carbide are needed to make 23.6 grams. So then the 23.6 grams of acetylene goes right here. Okay, so this is the known. And the first thing we got to do is convert the mass to moles of acetylene. Okay, and so that's old hat. We've done that before. The molar mass of acetylene is 26.0 grams. Okay, let me be consistent here. I need my 1 mole of acetylene. Okay, all right, so that's going to take us from grams to moles. Next we need to include the moles to moles ratio, the mole to mole ratio, which is simply 1 to 1. And now the compound that goes on top is the calcium carbide. That's what we're after. Okay, and I know this is 1 mole because the coefficient here in the equation is 1. And then we're canceling out moles of acetylene, and we look up here, that's 1 as we said before, so 1 mole of acetylene times. Now we have at this point we have the moles of calcium carbide that can be that are required to make this much acetylene. So now all that remains is to convert the moles to mass, and so we need the molar mass of calcium carbide, which is 64.1 grams. Sorry, my daughter is yelling. Over 1 mole calcium carbide. All right, and then the cool thing is that we can now cancel out. So grams of acetylene cancels, moles of acetylene cancel, moles of calcium carbide cancel, and we are left with grams of calcium carbide, which is exactly what we set out to do, right? And so let me go back to blue. And so when you multiply 23.6, or I'm sorry, when you divide 23.6 by 26.0, and then this is, this whole thing is just a big 1, so that doesn't change anything since we're multiplying by it. And then we multiply that by 64.1, and you should get 58.2 grams of calcium carbide. Okay. And don't forget, you need to have both the number, the units, we're in grams, and the identity of the compound for a complete answer. All right. Okay, let's try the next one. Let's see what the next one is. Okay, so same reaction, but this time we're being asked how many grams of water are required to react with this many grams of calcium carbide. Okay, so you can imagine a situation where maybe your boss comes in and says, hey, we've got 485 grams of calcium carbide. Let's see if we can make as much acetylene and calcium hydroxide as we can. Then it's left to you as the chemist to figure out how much water you would need to completely react with this much calcium carbide. Okay, so that's kind of the that's one situation where you might need to do that. All right, so we are trying to figure out grams of water. Okay, so that's mass of water equals, all right, this is what we're trying to find out. We're being given 485 grams of calcium carbide, and the first thing we need to know is what's the how many moles of this do we have. All right, so let me do something just a little bit different on this one, just to reinforce some things. Okay, this, as you know, this is the known. Okay, that's what we're given. Then what we need to do is convert this to moles, right? So this is the mass to moles conversion. Then we're going to multiply by the appropriate mole ratio, okay, because we have to follow the recipe given here. And then finally, once we've adjusted for the mole to mole relationship, then we have to bring this back from moles to mass, because that's ultimately what you need to figure out how much of this stuff to mass out. All right, let me go back to the blue pen. All right, so we need to know the molar mass of calcium carbide, which is still 64.1 grams, and that's 1 mole. All right, and then over here, I'm gonna like skip this mole ratio, and I'm gonna take care of the mole to mass conversion over here. So since we're going back to mass, we're gonna need the molar mass of the water, right? And molar mass of water is 18.0 grams, and that's 1 mole of water. And let me make sure I have my, okay. All right, so I want you to notice, I just want to point out a little pattern here. When we're doing mass to mass conversions, the first conversion factor and the third conversion factor have 1 mole in them. So it's 1 mole of whatever it is you're converting to moles here, 1 mole of whatever it is you're converting to mass over here. The first and third conversion factors will always have 1 mole down here, because they're just conversions between mass and moles, right? However, the mole ratio, this is the conversion factor where you must look at the balanced chemical equation, and you must use the coefficients that are up there, right? So now that we're ready to set up the mole ratio, we're trying to find out how much water. So the water is going to go on top, 2 moles of water over 1 mole of calcium carbide. All right. So it's this middle conversion factor where you must take the numbers from the coefficients, but the first and third conversion factors are always 1 mole. All right. So I'm just trying to help provide you some anchors there. All right, and when you take 485 and divide by 64.1, then multiply by 2, and then multiply by 18, you should get 272 grams of water. Okay? So if we step back and kind of think about what this all means, what this means is that if you take 272 grams of water and react it with 485 grams of calcium carbide, then you will consume both of those. Every gram of water and every gram of calcium carbide will disappear in the reaction, and it will all go into the products. All right. Okay, so I think that's pretty much all you need to know in order to do mass-to-mass conversions. And so good luck with your problem set, and we'll see you tomorrow. Okay, bye.